One of the largest refineries in the United States was able to reduce downtime and potential risk by bringing calibration to the plant floor, validating their entire vibration measurement channel. Hi, my name is Mike Scott, the Industrial Product Manager for the Modal Shop, and by using our Portable Vibration Calibrator, this particular refinery was able to test proximity probes on critical turbines and compressors. And everyone knows in the refining process, if your compressors go down, the refining process stops, and of course if your turbines go down, the cogeneration, power generation part of the process fails as well. So this equipment is classified as either supercritical or critical in this particular refinery. And in this case, the company's procedures called for the reliability team to test the proximity probes to make sure that the output was correct and that the vibration alarms were correct, and those vibration alarms can change based on the running speed of the equipment. So it's a rather complicated test, but proximity probes are the best indicator of the machine health for this particular equipment. And in this application, the customer was able to discover some mistakes that they had made with their cabling. They actually found out that the cabling was mismatched between the proximity probe, the extension cable, and the probe driver or proximeter, whatever term you'd like to use. And if you're familiar with proximity probes, you know that it's very important that the overall cable length to the probe driver be the exact length specified for that probe driver. So if it's a 5-meter probe driver, you must have 5 meters of cable connected to the probe driver to have the correct output of 200 millivolts per mil or 7.87 millivolts per micron. In this case, the extension cable that was used was the wrong length, and they were able to determine in advance of starting up the turbine or the compressors that the output was incorrect. Now, had they left this system in place without checking it, the vibration alarms would have occurred later than they wanted or with more vibration present than desired. And that was because of the way they hooked it up. The cable was too long and the sensitivity of the system had dropped from 200 millivolts per mil to about 175. And thus it produced a vibration alarm at a higher than expected vibration level. And of course that leads to increased risk and the potential for downtime because those turbines and compressors are not permitted to vibrate very much, especially in this application. So by finding this fault out ahead of time, before they started up that equipment, they prevented a potentially catastrophic situation. On a lighter note, they also improved their relationship in a way with the operations team. Many who work in the manufacturing or industrial sectors are familiar with sometimes the struggle between operations and reliability. Operations, of course, wants to keep producing and they want to keep generating power and generating chemicals, and reliability, of course, is in charge of making sure the machinery lasts over the long haul, making sure repairs are scheduled at the right time, and they're in charge of course, maximizing uptime. So sometimes these two goals can contradict each other, and it causes tension between the two groups. And by calibrating the system and proving to the operations team that the system, the vibration protection system, was working correctly, it really increased the confidence that operations had in reliability, and it helped the relationship between those two groups moving forward. I appreciate it very much. Thank you so much for watching. For more information on the Portable Vibration Calibrator, please go to modalshop.com. Thanks.